Okay, so yesterday we were looking at WebSockets and how we could use them to access real-time data from the blockchain. And we built a simple backend where we were interacting with the blockchain. You're welcome, Michael. And so essentially what we're going to be doing today is expanding on that idea, seeing how we could query more, build something like a simple application around this idea of WebSockets, and maybe in combination with APIs. And create something that is complete, perhaps. And then maybe tomorrow we can then start on webhooks and using subqueries to fetch data still. So, like I was saying the other day, the further we get into more and more complex data querying concepts. Just a moment. The further we get into data querying concepts, we're going to the increase on the efficiency and the level of optimization and customization that we can have with our queries. So, for instance, with APIs, we saw that we could get data, but only on request from the client. And then we looked at we were looking at WebSockets since the other day. And then yesterday, I think we started WebSockets yesterday. The other day we were doing practice for HTTP data querying requests. So today we'll be expanding on that idea of using WebSockets and seeing how we can query even more, much more information, rather than just a single event, emission of a single event, looking at probably more events and seeing how we can bring that information together in a way that helps us build a complete application. And okay, with that, I think we are good to start. So I'm going to share my screen. I hope it's visible. I believe it is. Because I don't want distractions, I'm going to push it in another window. Okay. So yes, my screen will still be visible. If you have any questions, you can always ask. I'll be able to find it here. All right. Okay. So I'm going to share my screen to start the application we were working with yesterday. I think it was on the desktop, and it was inside cohort 2. Was it? Yes, I think it's this. So inside here, when I open it, we had a client and we had a backend. So so I think this is the far we had come. Although we had so yesterday I was trying to make some changes to see that the error we were having yesterday is resolved. And I came to actually see the issue. It was a very small issue. So I'll put this back here. Okay, I think my application was just starting. So yes, we had this, then we were sending a message. We were sending a message to any connected client. So every connected client would receive the information that we were receiving in our back end. and we're sending it via this connection object that was defined here. So every time this function emitted the transfer event, would pass these specific event parameters of that specific emission onto the console, but also we would create a stringified message and then pass it to the clients that are connected via this WebSocket server. So yes, this was the ABI that we were using to define the interface of the smart contract. This was the smart contract address, so we created a smart contract instance with ethers.js, and then we subscribe to the transfer event. Specifically, this is the USDC smart contract on ETH mainnet, this smart contract, and this was on the back end. So I'm going to start the backend server so that we can test it again and then correct the issue and move further. So it is inside the server folder. So inside the server folder, I have the smart contract, rather the code for interacting with the blockchain. And for me to start the node server, I'll type this command node, then the file of the name of the entry file, index.js. So the server is now online, and this is a line that is typed here when the server starts listening for commands or requests from outside resources like clients or probably other backend servers. Okay, just a moment. Let me clear something here. Okay, so we have our node server running, and I'm going to start another terminal where I want to run the client server as well. So how do I verify that the node server is running? So I said every time someone connects to the WebSocket server, so these are files in completely different folders. I just brought them together because these are the only files I needed to interact with. Okay, so every time someone connects to the WebSocket server, would get the connection object, which will allow us to interact with the client themselves, maybe sending messages to them or waiting on messages from them. And so then the request that was used for establishing the handshake is this request here. We looked at that. So every time someone is connected, we type this to the console and then start tracking, or we subscribe to the transfer event, specifically that instance for that specific client. Although this would be an issue sometimes when it comes to data leakage across the instances of the WebSocket clients, but we can see how to improve that later on. But for now, let's leave it there. Okay, so we have the JSON object and we were passing it to the user, to the client, through this message as a JSON file, as a JSON object rather. So every time someone connects, I should be able to see new connection and then pass this data to them. That was the idea. But then it was failing, so I want us to see why it was failing. I'm going to test it in Postman first, then we can go to the front end. Okay, my server is listening at this port 8080, and this specifically is the host of the local machine. Always it's the default 127.0.0.1, and then port 80. The port, you can always choose what port you want your server to listen at. Then that would be your localhost socket. Okay, so when I connect, it should send me the message that there's a new connection right here. And what I expect is for these specific events that I'm tracking to start displaying like they display here. But we tried it all yesterday and it failed to display on the client because at this point this is acting as our client, but it's not displaying the messages. And the issue was really simple. So if you've worked with JSON files before, JSON objects before, you know that JSON objects cannot actually contain numbers. It can only have strings, or for data structures, it can have strings still, and then arrays, and maybe nested objects. But it can only be strings inside those nested objects or arrays. You can't have anything beyond that for JSON objects. So what I was doing, all these other values here are actually strings, but the value here is a number. So the issue was it could not convert it into a compatible JSON file, rather JSON object, because this is a number, so I would have to make it a string. And that's all that was really the issue. So I just have to change this to a string, just like that. When I run this server again, let's see if it actually displays the events. So of course it's disconnected, and when I connect again, it should be able to display the events. And you can see that. So it displays the events as a JSON object, each of them as they keep coming in. So it's 1733. And as more events keep coming in, it displays them, the latest at the top. When you watch it here, you can see that the events are actually changing. I'll just watch the time here. So it is 1734, and that number of milliseconds. You see, it's like a stream now. I have this very specific data point that I've subscribed to, and every time there's an update from the RPC via the WebSocket, I receive the updates directly. So I subscribe to the transfer event, but I can subscribe to any other event on this smart contract. Let's see if it displays on the interface on the front end. So this is the back end, and this is the console of the back end. So I wanted to open the client, and inside the client, I think I have a event tracker. When I start the front end server or the client server and then run it here, perhaps. Let me run it here. 5173. Let's see what my client server displays in the console. So this client server would now connect to the WebSocket, and you see the data is actually being displayed. And this is what we expected yesterday, but it wasn't showing. And from what you can see, it's actually a stream. It does not stop to stream the data. For as long as the transfer event is being called, all the information will be displayed here as it's being displayed right here. So this is the kind of data that is used for things like trading charts, OHLCV data, the kind of data that continuously comes from those endpoints. Like the client no longer has to query that data from the server. The server simply responds every time it has new information. And so this is what we're doing with WebSockets, and that's what happens for most of those data points. And you can use WebSocket for a number of things. So we're going to subscribe to a different smart contract and a different event, or maybe we'll start with a different event on this very smart contract and see if it actually works. But we now have this data on the front end, as you can see. So this is the transfer event we were subscribing to. Now, what I have to do now is pick this data from console and bring it to the application itself. But how do I display it? Anyone could suggest a data structure that I could use, which could continuously update and allow me to display information on the front end. Any suggestions? I could use suggestions. Anyway, so you guys can take time to think about it. Meanwhile, I think the issue we had yesterday was just that. That's why the data wasn't displaying. We just had to change this number to a string. That is all. yes, continuous, that the data continuously feeds into that data structure and then allows me to continuously display it on the interface. What data structure do you think is most appropriate for that? Could it be an object literal? Could it be an array? Could it be a simple scalar type? We use an object. Okay, I could try using an object and see what happens. Because now, by the way, one of the things that seems very trivial, but is a real issue, is data visualization. It might not be, and data visualization isn't just about you using it as input into charts or data visualization components like maybe pie charts or bar charts or donut graphs, but also just displaying the data on the interface. You need to really understand how JavaScript data structures work and how you can access the elements via the standard data querying processes or syntaxes. For instance, if you're going to use an array, you might access objects or elements on the array differently from how you would do it with objects. And then utilizing all the methods that are attached on these specific objects and their prototypes to make sure that you actually do the correct thing. Now, especially in frameworks like React, sometimes there is a bit of an issue with how you display data. For instance, you cannot display objects directly on the React interface. You would have to use something like an array and maybe use the map function to display that information. So let's see what it looks like now and attempt to display this data. This single file here, it looks small because we're not doing very much. But setting this whole thing up like we did yesterday, if you remember, and then coming to the front end and setting it up so that it can listen to information coming from this back end. And then also this back end listening on to things that are information that is coming from the blockchain. It's a whole process. But then if we cannot bring this entire process to completion, then everything we did does not make sense. So now we have to bring this data to the interface. But you can see it's an actual object. An object literal, a JavaScript object literal. And from here, when I look at it, so I was passing it here on the front end, and that's how I ended up with an object. So now what am I going to do with this object? For me to be able to display it on the interface, to display this data on the interface, maybe I can store this object in a state variable and then destructure it by dot notation when I'm displaying it, because objects directly do not display. So you have to access the components of the object. And I can test that right now if I try to display this object. Let me say maybe I'm putting it inside a component and then just displaying the object itself. And for me to have the object, I want to pass it directly from, let me first define a variable here and pass this object. Let me call it data. So I'm passing that object, and then here, I'm just displaying it on the console still. So when this refreshes, it should still display. Okay, it's refreshed, I think. So when it connects, it should still do the same thing. I've only shifted the object definition, unless there's an issue. So it will probably run. But you can see this other client still receives the information. Maybe the only thing I would say about this kind of data is that what you've received is fleeting, in the sense that you cannot have access. If you don't have a state variable that is holding all this data continuously, everything else is just gone, because each of these objects is coming independently, one after the other. So the previous one is no longer into the state variable that you're probably holding it into. Maybe it continuously replaces the original object. Okay. Yeah, okay, the data is there. So now I want to pass all this data into the state variable I declared set data. So this is now going to be the object itself. So now the object has a number of properties. There is the from, then the to, then the value property. And you can see I continuously receive this data. And every time I make changes, because React re-renders every time you make certain changes, the application also re-renders. And down here on the console, on the node console, I should see a message that keeps telling me, oh my god, the events are so many. The event emissions are many. So I'm looking for something that says new connection. But the events are just continuously flowing, so I don't even have, there's no possibility of me seeing anything like a new connection. Now all this data is live, by the way, insufficient resources. Okay. Let me just focus on fixing what I'm doing here. So app.jsx. Now I'm passing this data to the state variable, and I want to destructure it here and display maybe inside this component. Inside this container rather, I want to display what is stored in data. So what I'm going to be saying is probably if data is undefined, or if data has no value, display something like this probably. But the page is loading. Or maybe waiting for data like it told me. H3, let me leave it at that. H3, waiting for data. So otherwise, if the data is there, then what should I display? Yeah, this probably is perfect. Data from, data to, data to value. So this will be a destructuring of the array, but let me type it and not let my assistant do it. H3. Yeah. So if this was the heading I'm going to display, in case the data has been returned, so this is how I'll destructure it. Probably say where did the value come from, whatever is being transferred. It's defined in data.from. I think data.from, because that's the object that I'm receiving. Then where's the value going to? Let me put a pipe symbol here. Where did the value go to? It went to data.to, I imagine. Yes, data.to. So right now we're still waiting for data. That's what it's displaying here. And excuse me, how much was the value that was transferred in that transaction? Data.value. So that's essentially it. And now it should be able to work. So this is on my front end. It doesn't impact the backend server. So when I refresh, I expect to see that here. Reference error said set data is not defined. Which line is this? 920. Set data. Okay. I think it was just something I was doing earlier. So I expect to see updates there. Waiting for data. So when the data starts to flow in, then I expect it to display that data. Every time there's an update, it should display the update instead. Yeah, just waiting on the data. Has it connected? So the backend server is still on, and I expect it to display. Okay, let me try to revert what I had changed and see. So instead of me putting the data there, let me just replace this and see if it displays it. Okay, I expect it to connect automatically, of course, because everything in here is in the component. Or maybe I could even put it inside use effect so that the events are tracked after the application has rendered. It's not displaying. The data returned. So let me first comment this out and revert it to the original state. Might be a simple issue again. Did I tamper with anything around connection? So this is for receiving the message. If it's connected, it displays that. Okay, the server is still on. So why is it not connecting? Yeah. Connected to the server. It's taken a while. I believe we should now start displaying the data. It's taken quite a while. Okay, how I know it's the server is still running is because this other client still receives the events. I think this is just having an issue with connection. Because it's already connected, should be able to display. Okay, it's very strange because both servers are running on my PC. If they're both slow, then okay. I can't figure out what. Try refreshing it. I expect the events to start streaming anytime soon. The event emissions, rather. Okay. Let me try restarting the backend server. Or maybe this very server. So this one's running perfectly. How do I know? It's already connected to the WebSocket server, so it should be able to receive the messages as it is defined. Every time it receives a message, it returns that data on display. Unless the RPC has got an issue. So this is something that is a possibility as well, and I should point it out. So this is the RPC we're using for accessing the event, that specific event on that smart contract on that chain. So sometimes RPCs could go off because they are actual nodes. They are simply like peer servers on that blockchain. So issues could arise, and maybe the server is offline for some reason. Maybe it has an issue with internet connections and it's off. So sometimes it's not really that your application is failing, or maybe because the dependencies or the external resources you are relying on for the data that your application needs are also failing. So we can attempt to change this WebSocket server itself. Okay, we disconnected. Let me try to change it and try using a different one. And then restart the node server. See, I had all these connections. Okay, the front-end server is running. I am going to change the RPC. I'm going to open chain list here. So we're working on Ethereum mainnet, I believe, because that's where that contract is deployed. So if you have any misconfigurations, your application will not work. For instance, if you used an RPC on a different blockchain and you are tracking a smart contract on a completely different blockchain, then you will not get the results you expect. So we can try that out first. Maybe let's try out a different RPC, WebSocket RPC for Ethereum mainnet, and then try using an RPC from a different blockchain. See what happens. So that is just another RPC we could use. And when I run it, the server is now online. And then I'm going to connect again. And hopefully I receive the event information. There's a new connection already. So anytime the transfer method is called, I should be able to receive. Okay, so it's working. And as well here, it's working. How about on the front end? This is connected, should be able to work. Maybe the other issue is, sometimes if the connection fails, I should be able to, so maybe the RPC was a problem. So sometimes when the connection fails, probably if I had an internet connection, I should be able to reconnect, and I can define logic for that, or I can use a third-party WebSocket library on the front end for me to be able to continuously connect. So I'm going to return my code on the front end here. So what I was doing is I was passing this variable into the state variable, the data object rather into the state variable, and then I was attempting to display it here. What am I displaying? Okay, display waiting for data. It's still displaying waiting for data. Why is that so? So when I receive the message, I modify the state of the state variable here. That's ideally what I'm doing. I had not defined data. Sorry, I hadn't defined data. So does it work now? When it connects to the web server, I hope to receive that data. Is this running? It is running, yes. So you can see the transactions are displaying. As the data comes in, all the transactions display. I'm sure you've probably seen this on maybe some platforms. So we're going to now switch this data. So this value is in ETH, and we're going to now modify it so that we can see the actual value And we're going to use a specific method still on the ethers.js library that would convert this value from way, which is the value denomination in which values is transferred on EVM chains, into something that we can clearly see on the front end. Okay, maybe the heading 3 is too big also. So this is something that you could do. And if you can see this data on the front end, so many applications actually display data like this. And this is how you would actually typically do a data fetch request from a WebSocket server. Let me modify this. Maybe heading 3 is too big. Let me make it an H4 or paragraph perhaps. And then I want to modify this value so that I can see it in form of ETH and not way, because this is way now, which is the smallest denomination of currency on the EVM standard chain, on the EVM chain standard. So I'm going to modify it and make it ETH so that we can see it. Okay, so what am I going to do now? I'm going to import a specific library. I'm going to import it on the client. I think there was something like event tracking here. Then inside here, this is where my application is. You can see that this is where the node modules are and the SRC folder. So inside here, I'm going to install Ethers. So I installed it on the back end. These are completely two different applications. They just depend on each other. That's why I'm installing it again on the front end. And some of the front end components may not work on the back end, and some of the back end components may not really work on the front end. One of them is a WebSocket provider. It's very cumbersome when you work with it on the front end because it's not designed to be operating in an environment like that. There are certain things that the front end environments do not have that you would typically be able to work with if you are working in the back end. So the way we're going to use ethers.js on the front end is different from how we use it on the back end. For instance, if you wanted your back end to sign transactions and broadcast them to the blockchain, that's not something you can do on a client. You would have to do it on a server or on a server side, in your server side code. So as we wait on ethers.js, we could actually do what we're supposed to do here with ethers.js. And I'm going to import that specific method. Import, it is called format ether, and we've seen this method before when we were working with APIs. We used it. So I'm going to import it from ethers. I think it's under utilities. Yes, it's under utilities. Or I could also get the same method from VM. So VM is a wrapper library of ethers.js, but it also does its own things that are different from what ethers.js does, although it really wraps ethers.js. So all the functionality of ethers.js can be found in ethers and more. And so now we have all the data here. We're receiving it on the front end. It's reloading, of course. It's waiting for data. And when the data comes in, you'll be able to see it. You'll be able to see it there. Someone asking a question. Okay. So we have ethers.js installed, and the application is still waiting on data. It really picks it slowly. I don't know why. So I'm going to call that method on this value and convert it back to ETH, a number that is more humanly readable than way. So I would compare it to cents in a dollar, rather than displaying your funds in terms of a dollar, you display them in the smallest denomination, which is cents. So think about it, $1 is 100 cents. So if someone displayed 100 cents, they're typically telling you that specific value is $1. If there was 1,000 cents, what they're typically telling you is that is $10. But it becomes quite confusing to people if I continue to display the value in dollars in terms of cents. It can easily be misconstrued, and probably someone might think 1,000 cents is $1,000. So that's the whole concept of the whole purpose of this function, is that it converts the value from the smallest denomination into a denomination that is easy for us to read, to see and read. Okay. I don't know why this connection fails at times, but of course it should be able to connect like it did just a few seconds ago, and we saw that data. Okay, so today I'll really be going around some of the things that are important and critical about these kinds of interactions, especially when you're working with blockchains. So I just want to display this. It takes a while, so I will let it do that. Maybe when it connects, we shall find it. So we can stick to this other client. It's a little bit faster. And I think you can already see that all the information is being streamed. So if I changed, although it would not make sense if I don't wait on this. Okay. I just want this application to read and connect. I don't know, there's some kind of overload or something. Let me try restarting all the servers. So this is off. The front-end server is also off now. So I'm going to start with the back-end server. I'm going to restart it. So it's online. And now the front-end server. So they are both on now. Connected to the WebSocket server, yes. So I expect it to stream in the next few seconds. So why it fails, I don't know why. So you can see it displays the value here and shows it to me in ETH instead of WEI. So it's the display is fleeting simply because the transfer function, like I mentioned yesterday, is one of the most actively invoked functions on these ERC20 contracts. So it makes it really, really difficult for you to see any data for a very long time. So it streams and displays this data right immediately as these events are called. These events are emitted in the functions where they are called. Okay. So I'm not going to go into styling this specific application. I wanted to focus on the concept of data fetching using a WebSocket, and I think we have successfully done it. At least just one of the parts that you could think about. So what I wanted to do, you can see this is amount in ETH that is being transferred from that address to that address, and this is an ERC20. So the value is actually not in WEI. It's not a native currency, so this has to be format units. Because this is This is USDC, so it has 6 decimals, not 18 decimals. Format Ether is a method that converts Ether, which has 18 decimals, rather Wei, which is an 18 decimal representation of ETH. So it would divide it by 18 zeros. Otherwise, this is specifically USDC, an ERC20 that has 6 decimals of value. So you'd have to convert it with the format units method, where you specify the number of decimals for the specific token. So yes, now I can see it in the correct denomination. This is USDC. Yeah, that's the correct denomination now. So USDC, like I said, is a stable coin, and it is specifically pegged to the dollar. So you would be able to see its value only fluctuate in very small ranges close to the value of the dollar. So now something very critical here is the configuration in the back end particularly. I want to focus on the back end. So you can see that our specific WebSocket connection here to this specific RPC streams data for us from the Ethereum blockchain, Ethereum mainnet. So very importantly, the WebSocket server must be on the correct chain. The address must be of a smart contract that has been deployed on that specific chain. Of course, the ABI can be the same even if contracts are deployed on different chains, as long as they have exactly the same code or the same code base. They can have the same ABI, but two very important things: the RPC, the WebSocket RPC, and the address have to represent contracts, have to be of the same chain. So the smart contract, if I put a smart contract here that exists on a different chain, I would not be able to fetch that data. It will actually raise errors. So we can try this out. And these are things that would not typically raise exceptions. An exception is an error that you cannot go beyond, that you would have to verify before, that you would have to solve before you can continue execution. They would not typically cause exceptions. They're just simple misconfigurations, but their implications are severe. Yes, please. Sorry, Kaxv, your microphone was muted. I didn't hear your question. Yes, you are.
So I was wondering, this is very exciting, prices that leads to me. I wonder if that is something to be used for displaying the parts, the graphs that we see in the logo of the trading platform, or especially something that we're going to be able to see the prices to change.
Yes, it's exactly the same mechanism they use, but this is something. Let me show you something here. So what happens is this data would come in form of a price points. So every single returned value comes with 5 price points, and I'm going to explain them on the GMX platform and also display something for us here. So I've been talking about OHLCV this whole time. Let me get into a simple explanation of it. Then, unfortunately, most of the resources we can get OHLCV data have it rate limited. That means you cannot access it if you've not paid for it. But probably tomorrow we shall look at a payment mechanism that is Web3 native called X402. that allows us to pay for services only when we need to pay for them, and pay for them in crypto tokens instead of having to maybe connect our cards and all those other payment mechanisms. So when you look at this card, this candlestick, this red candlestick, I want to zoom in as much as I can. Okay, I'll demonstrate it on the green one. Maybe let me actually get a candlestick so that I can explain what OHLCV actually means and how this data is returned onto the front end through a WebSocket. Meanwhile, so usually what happens is all this data is brought in at a specific time, but then it is passed into a charting library. This is a charting library that can allow you to display candlesticks on the front end. I want something that has a documentation. I think there's a library I used to use, d3.js. That's a charting library, but there's also, I think it's called eCharts. Yes. It has a number of charting patterns you could use. All you have to do is feed data into them. Apache eCharts, yes. So what does a candlestick actually look like? And how is the data? So there are two types of candlesticks. There are bullish candlesticks and then bearish candlesticks. But they typically represent the same thing. There's always a body, then there's a wick. These are called wicks. Wick like W-I-C-K. The one for those lights that actually use a wick, using a capillary mechanism for fuel to go upwards. So what typically happens is it has a number of parts. This is the body, that's the wick, like I've said. So usually when the candlestick is green, what that means it was created from a lower price point and closed at a higher price point. Every candlestick exists for a specific period of time. So for instance, if it's on a daily chart, every candlestick exists for a whole day, builds across a period of a whole day. If it's a 5-minute candlestick chart, every candlestick builds across a period of 5 minutes. So along that period, within that period of 5 minutes, the candlestick would open high at a lower price point, then close at a high price point. So at the 5th minute, it would close here. If the candlestick is red, that means it opened at a lower price point, and the price, by the end of the 5 minutes, the price had dropped up to this point. So as you can see, that's the open, that's the close for a red candlestick. Then for a green candlestick, the open is low, the close is high. But then this, within that period where price was fluctuating, within that specific period, maybe 5 minutes, this is the highest it would have come in that period of 5 minutes. I'm using 5 minutes as an example. And this is the lowest it would have come within that period of 5 minutes. So it could close here, then maybe price drops and goes high, then comes back in the middle. But by the end of the 5th minute, it closes here and moves on to the next candlestick. So that's how a candlestick chart is built. After a specific period, maybe after 5 minutes, if it's a 5-minute candlestick chart, a new candlestick is created. So might start here, maybe from this point when the price was this high, and it jumped up to this point. So the new candlestick opened at this price, then fluctuated, went that high, went this low, continued to fluctuate, and by the end of the 5th minute, it closed here. So now OHLCV data is what represents these specific points. What was the opening price? What was the closing price? What was the highest it went? What was the lowest it went? So it's OHLCV. So it's OHLCV means open, high, low, and close. Then the V represents the trading volume within that 5 minutes period. So all that data can be returned to you in real time through a WebSocket. And I know a specific data streaming application, rather indexing tool that has OHLCV data. I think it's covalent. So with chats like this one, with chatting platforms like this, chatting libraries like this, you can display this data as soon as you receive it. I think under examples, I should be able to see a candlestick chart. So I've used this library a number of times for different chatting. I don't know if I have a candlestick chart here. So it has all forms of charts. A line graph might be there. I think each chart doesn't have a candlestick, but it has so many other forms of charts that you could use to display data on the front end, dynamically, by the way. That if any changes happened within the data, the front end would automatically change. And this is where WebSockets would come in handy, because the data will change in real time as soon as the resource on which it's dependent changes. Even the display, I think I can see a Shanghai index here. So look at this, then there is OHLC chart. So this would be the kind of chart that you feed in all this data as you receive it, and as you can see, you can use this. Okay, there's this kind, but this is really the same thing. It's a candlestick chart, only that it displays it differently, but this is still a candlestick chart. So you can see this is how you would enter the data in JavaScript. After receiving it from your client, from your server, you'd put it into these specific data structures as they are defined here. You would pass in the raw data as a parameter. So this is how probably you would receive the data from the back end as a raw data array. As I can tell here, this is an array. So I could restructure my application. I think it's right here. So I'm receiving an object here. But if you remember when we were looking at APIs, there were some times where we were receiving arrays and you could restructure your array in a certain way. So I could do the same here. So I'll receive it as a raw array and then simply just passing it in here. Everything else is configured to be displayed on the chart through this function split data. You just receive the array and then make sure it has the components the way they are expected, OHLCV, and it would get everything for you. Define the specific points on which these price points should be put, and then it configures the scale of the graph itself based on the range of the data that you're providing to it. And you can see that low point, high point, opening point, close point, and all this information is arranged and displayed on the chart according to this configuration. So all you have to do is just provide the data source and make sure the data continuously comes back from that source and is displayed for you. So you can see this scale is dependent on the range of the data that you're providing in your original array. So this is the code you can edit. There's a full piece of code here where you can import everything from eCharts. And this is something you can do from within React. You see that? So if I had this specific code base, I can actually copy this code base if I wanted to display this chart, and then I should be able to display the chart. Because then, when you look at this, it's already creating an object for us, an element for us that we can fetch from the front end and then modify it according to this data structure. So this is how you display OHLC data. But the only service I know that has this kind of information is not free. So I would have to pay for it probably tomorrow if I have some tokens. I don't know if it's compatible with X402, but we can work with it. I would have to do, so X402 is now here, a payment standard. I think it might actually be compatible if they have it here as a mechanism. So this is a Web3 native payment standard. And if you're familiar with working with APIs, I'm sure you've seen this error at a certain point in time where you have a specific API key, but the number of tokens it's required to have, maybe for free access to the API are probably used up, or the period that you paid for, all the access resources that you were granted have been used up or exhausted, and now you have to make a payment beyond what you had originally made. So it will raise this error for you and tell you there's a payment required for you to fetch that information from the API. And for those that have been attending the sessions, I'm sure we saw this error when we were starting to work with APIs. There was a specific API key I had that had exhausted the resources to access that API. So it returned this error exactly as it is, 402, payment required. So there's a specific payment protocol that has been designed for Web3, paying with tokens. That means crypto tokens themselves, rather than having to connect your cards. So that's what I want to attempt to do, but I don't think I can do it now. You can actually read about this, and I think it has a destination anchor, so I'm going to share this link. And for those that are just new to Web3, you can look at it and probably see if it makes sense. Why X402 is a better standard, or maybe a preferable standard to working with an API key. I could share it in the group as well. Central code. The central code. So yeah, just in case we don't, we forget to get it from here, you'll find it there. So the streaming API, particularly for Gold Rush, can provide all HLCV data, token stream. So you can stream this data from the Gold Rush API, but it's not free. So that's the issue I have with it, and I'm not ready to pay for a service for a whole month just to use it for one day. So that's where the X402 protocol would come in very handy. So we've looked at how you can, you'd have to get into the details of how you can use eChat to display HLCV data. But it's really, if you can receive it from a specific service, then you can display it. Because the libraries are here, the chats are already here. You just have to configure them with the correct information in the correct order. If it comes in a different order, you can restructure it for it to fit the expected order of this specific chat. And yeah, you'll be able to display it and build an entire trading platform beyond that. Of course, it's bigger than just displaying the chart, but displaying the chart is a starting point. So alternatively, you can also display it like this using the Shanghai charts, because candlesticks are originally a standard of the Japanese themselves. So actually, this is a very beautiful design. You can see how it identifies them. Each item, open, close, low, high. Exactly how you would display them. This would be the open, this would be the close, this would be the low, this would be the highest. And if you look at them critically, you will see that the high is definitely higher than each of them. This is 2362. 2362 is higher than all these other values. The lowest should be lower than all of them. 2287, it is lower than all of these. The open should be, now that depends. Is it a bearish candle or a bullish candle? A bullish candle would be starting low and ending high. Bearish candle would be starting high and ending low. So I would tell by the difference between these two. So the open and close are the same. So this is something that would look like a butterfly, rather like a plus sign. I don't know if we can see anything like that here. So you don't have to worry. If you're not a native trader, some of these things might not make very much sense. So if the open and close is close to the same, it would look something like this, like a simple plus sign. But you can see the price points are actually defined on the lines right here. So it would restructure the scale based on the data that you have fetched, brought into it. Find the lowest point, find the highest point, then define the different segments. It is quite interesting when you think about it, because a scale is a very important thing and it's dynamic. Based on how the screen is the range of data that is being displayed on the screen, both by scale and range, both by scale and point in time, it will restructure the scale. So if I zoom in, the scale changes. If I zoom out, the scale still changes, but it displays all the data. So yeah, I think this is a very good depiction of how you can work with it. Even the dates are displayed here, like when specifically was this point in price in time. So probably this is a daily candle, a daily chart candle that displays candles for every single day, compared to the ones that would display candles in a smaller frequencies of time, maybe 2 minutes, 5 minutes. Charts can be of different frequencies. But yeah, that's how you would display HLCV data using these charts, and if you can receive the data. Another library you could use is this, the D3. This is one of the best libraries that I've used for data visualization. It's actually one that is used by ML engineers and analytics and data visualization professionals. Let me also paste it here. So if you're interested in data visualization, because what we're doing is fetching data, but you might not want to exactly display it as raw data. You might want to, get some kind of analytical insights from that data and visualize them. So you could use libraries like this. You could use eCharts. This is one of the most basic charting libraries that you could use. So yeah, that's it. And getting back to what we were doing, I think we've understood what a candlestick is. Streaming data, we won't be able to do that. But I'll look at X402. After we do it, probably I'll see how we can use it here, if it's compatible. Okay, so we have this data and we think we have done enough with this. So I was trying to demonstrate why it's important for these configurations to be accurate. For instance, I'm going to copy a smart contract address of okay, I think the server is running still. It's disconnected. So I'm going to copy a smart contract address from a different chain and see if it would actually display a smart contract address that is exactly of the same token but on a different chain. So that will mean that the WebSocket is on a completely different chain, and then the smart contract is deployed on a completely different smart blockchain. So what would typically happen? There's a misconfiguration. We would not expect to see this data. But the worst that could happen is that you will not see the data. So you must be very aware of what is happening. Every time you're trying to work with blockchains, the biggest issue is configuration, and to know which parts you're working with and the purpose of those specific parts. So let's verify if this server is still doing what we expect it to do. When I run it and attempt to, so it's running, it's online. When I connect, it tells me there's a new connection, so I expect to see streams of data, maybe in the next few seconds. So it's working. And how about if I change this smart contract and use the smart contract that wasn't deployed on Ethereum mainnet, but maybe deployed somewhere else, maybe on Ethereum Sepolia, or let me still use a USDC address and see what happens. Even on the front end, I think it's working. So now you see the issue. So the backend server closed, but this one disconnected. Because the backend server closed, this disconnected, and it doesn't have the logic for reconnecting just in case the backend server went off for some reason. So that's one of the issues that we would have with a native WebSocket API on the front end that would require us to use something like a React WebSocket library that would allow us to have all these features added, that when the backend server disconnects, the front-end server continuously tries to reconnect just in case maybe there was a connection issue with the internet. It would try to reconnect again and attempt to, establish that connection. So that's why this data isn't changing, because it's not streaming anymore. It doesn't have access. So I would have to refresh it. This is the typical response to what you would do in case your server wasn't connecting, but you would not know that as an end user. You would only see something you don't expect. Maybe the data isn't changing. So the typical response would be you simply restart the server, or rather refresh your application to be able to check if you are receiving the correct information, or maybe something is wrong. But that doesn't work in applications like games. It can be very costly. And it's very important to know which applications you can use some libraries in and which you cannot use some in, just for purposes of efficiency. But we'll continue to look at these things in detail as we move forward. When we get into subqueries, we'll even see this further. So I wanted to go to the USDC addresses. So USDC is a stable coin. But what stable coins really are actual smart contracts. They're just stores of value. So you would exchange your fiat currency, maybe $1 or Uganda shillings, for that stable coin. But it's simply just a ledger of value that is stored on chain. Just like every other token is anyway. But when something becomes so reliable as a store of value, it itself becomes a monetary medium. Think about gold. Gold up to these days is used as a store of value. It actually is used to back up fiat currency. But back then, gold was actually being used to exchange. Someone would typically give you gold, and I think it's still used even in some parts of the world. Someone gives you gold for something in exchange for something else. So when something is reliable as a store of value, it itself becomes a medium of exchange. Just like blockchain tokens are. They are stores of value, just ledgers or records of transactions that have happened. But because of their reliability, the security that is associated with them, they become so reliable that we start to use them as money. We give them trust as we would typically give to cash as we know it. But that's a philosophical discussion for another day. I was just digressing a little. So I want to get a smart contract here that is not deployed on Ethereum mainnet, but still represents USDC as a token. And I'll use one that is still on the EVM, on an EVM chain, maybe Celo. Let me pick one for Celo. So Celo is also a blockchain just like Ethereum, following exactly the same architecture standard. So it's EVM compatible. Now this smart contract is deployed on Celo. It is not on Ethereum. How do I verify that? When I click on this link, it will show me the smart contract deployment on the Celo Blockchain Explorer. Let's verify if it's actually on Ethereum. There might be another smart contract on Ethereum that might have this specific address, but it might not be exactly the USDC address. It might be something else, an entirely different protocol. But it's also very unlikely that you'll find a smart contract with exactly the same contract address on a different chain, unless it was mined with a salt. Shall see what a salt is when we get into smart contracts address mining. So this one is on Etherscan. Do I have it on Etherscan? No, I was opening Etherscan with C, ends with C. So yes, I think there's a smart contract that ends with C that has this specific address on Ethereum. Because this is Ethereum mainnet. This is a blockchain explorer for Ethereum. Token transfers. But it's not USDC. And yet when I come to the Celo blockchain, specifically to the Celo blockchain explorer, it's taken quite a while. Let me look at its block scout equivalent. Is this a smart contract or an account, just an externally owned account? I think it's just an EOA, one that is not very active. You can see its last transaction was 62 days ago. Now, because the smart contracts have their addresses and their code base open, someone can even recreate their own token. It is so easy, even with ERC20s. Where the issue comes in is in the token economics, where you have to associate the value of that token with something that already exists, so that it derives its value from that association and then, build its value from there. Maybe we could talk about that in the spaces as we continue to share this blockchain information. So we can't cover everything at all, but we also continuously will be having spaces, X spaces every Thursday. So you can always come into the space, and whatever the subject of that space is, it's something that probably would, open your mind to a different perspective of things, and specifically in terms of blockchain. Okay, I'm looking for that contract address, but I want to see it on the Celo blockchain. So what chain am I going to look at? Celo. Hope I can find Celo. Celo is here. Oh, my internet is just a little bit slow. Is this still streaming? Or did I stop it? I think I might have stopped it. No, I didn't. So on the Celo blockchain, when I check this address, it should represent the USDC smart contract. So you can see this is the USDC token, and the contract is verified as the USDC token. That's the token name. But then when I come to that very address on Ethereum, it represents a completely different thing. It might be a token, but it's not the USDC address. So now we're using a WebSocket URL, RPC URL of the Ethereum chain, and then we're configuring it with a token on the Celo blockchain. So what would happen? I wouldn't expect to get any information. Or probably, if that event actually exists on that smart contract, I might get information I don't expect. Or even if that contract exists, does it have that event at all? And even if it has the event, does it represent the kind of information that I want? So configuration is very critical. Now let's attempt to do that and see what happens. So I've misconfigured, deliberately I've misconfigured this server, and I cannot expect to see any events. And I can show you why. Because the very last transaction on this address or this smart contract was 62 days ago. So I don't expect to see any emissions. And when I look at the Celo blockchain here, just the transactions, you would see transactions happening in seconds. But although because Ethereum is also one of the most actively used chains, the transfer function of USDC is called very often on that specific smart contract that we've been interacting with. But then Celo, on the other hand, much as it's EVM compatible, it might not have just as much activity as Ethereum, the chain itself. But let's see, when was the last transaction on this chain? And then we will try to switch the specific WebSocket URL from the one of Ethereum to that of Celo, and then see if we actually get the results we expect. So up to this point, I do not have any responses. And you can see there is no error you will see. in terms of the configuration. So you have to be very sure. Is the configuration accurate? So the things that you should always look out for in any blockchain integration on front-end services or back-end services is one, the RPC, whether it's HTTP or it's WebSockets or it's working with custom transports. You need to be sure you're connecting to the correct chain via the WebSocket via the providers. So this could be a WebSocket provider or a browser provider. You need to be sure what chain are you connecting to. And then two, what address are you interacting with, smart contracts specifically? Does it have a is it deployed on that specific chain? So you can even verify it by going to the Blockchain Explorer and seeing if it has a specific smart contract deployed at that address. And if it doesn't, then probably you're misconfiguring your application and you need to, find the correct parameters for the configuration. So 16 minutes ago, so it's not very active, but you can still is the transfer function that is being called on this specific token. So USDC is not a very actively used token. I think the one that is most used is CUSD on the Celo blockchain itself. So CUSD is also an ERC20, and I hope to see more activity on CUSD than USDC. As you can see, it's also approximately $1 in value. So it's pegged to the dollar. It's actually called the Celo dollar, yes. And I can look at its transactions to see when it was last active. Okay, so I don't see any results up to this point, simply because of one reason. There's no smart contract deployed at this address on Ethereum, because this RPC or this specific node is of the Ethereum blockchain, but I'm trying to access it via a smart contract that is deployed on Celo. Whether to use it to access a smart contract deployed on Celo, they're entirely different network infrastructures or blockchain infrastructures. Okay. I think I need to find something a little bit more active. Base is one of the most used chains. Now I want to shift and see if we can get the information on Base. So it's one of the cheapest in terms of gas price. So gas price is the value that you pay in exchange for changing the state of the blockchain. In exchange for transferring value, it's like the fees that you're charged for every operation that you do that would modify something on the chain. Either it changes balances on your account, or it interacts with a smart contract and modifies its state. Everything that you do that should modify the state of a blockchain would require you to pay gas in exchange for that modification to happen, or in exchange for you to transfer funds especially. So this is USDC on Base. And as you can see, it has a much higher activity than Celo as well. Let me close this. Because for Celo we saw this is ETH. So let me change this to Base and see what happens. So this is the smart contract of Base, specifically USDC on Base, but I want the token address. So I'll copy it from here and see if the same thing happens. So let me refresh. Action. A lot more actions are happening on this specific token, surprisingly. And these tokens are upgradable in terms of their code. So you might see functions that don't really exist on other chains, but they exist on these specific chains in the token deployments, token instantiations of these different chains. But they are really representing the same token and the same value denomination. So the transfer function is called a little bit less often here instead. or we can also track a different event. And it's not just events that you can track, although it's the most commonest kind of data points that are tracked using using WebSockets. So I'm going to now go to Adex. So Adex is a platform where you can do exchanges and transfer your tokens from one token denomination into another. I hope I have Uniswap on. I don't know if Uniswap has a. Does Uniswap have a deployment on this? This is a Uniswap token. Unitoken. I want the protocol itself. Let me look at Li-Fi perhaps. So do not worry about these names. They represent addresses. They represent actual protocols. What a protocol is a set of instructions that is designed for a specific purpose. So usually these are designed for you to exchange value between different tokens. Yeah, I think you can see this. I don't know if it has any events, this specific function, start bridge tokens via Mayan. They are very complex protocols, so you would have to really understand how protocols are built. Oh, this actually has three events. One is order created, the other is forwarded ETH, the address of the Mayan protocol, and this is probably the call data that has been encoded. But I'm going to specifically look out for an event that I think might be easy to fetch. Order created, yes. Now the issue I would face with this is that this data type is not native to JavaScript. So I would have to find a way of converting it into a data type that is JavaScript native so I can display it on the interface. Otherwise it would still come as a string. And if I want, I can destructure it. Just like you can get a buffer object in JavaScript and convert it into a JSON object, you could do the same with bytes. So probably I want to track this event on these smart contracts. So I'm going to type it's is this on ETH? This is on base. Yeah, it's on base. Now I'm going to add this to. Let me create a different ABI because I'm sure this is not the same token, same smart contract. ABI base. Okay, bytes 32, so I should expect to see this. And what is it an event? Yes, it should be an event. So an ABI can have both events and functions, but we shall see that. It becomes very hard for me to explain certain things without getting into some of the details of blockchain mechanics, and yet you would have to explain them as well. So I'll use this ABI and maybe also change the address to something that is on base, which is of course this smart contract. So we saw what misconfiguration could do, the scale of damage it can do in terms of causing confusion. I think this is not a very often called function. Swap token single is not a very active contract. I want something that is hyperactive, that I can see results every single minute or every single second perhaps. Unless someone knows a different protocol I could use other than the USDC contracts. I think Ethereum might be the most active, and maybe OP mainnet. Not that the others don't have activity, but they're not as much active as Ethereum would be. Create position. Let me look at this. This is on optimism, yes. In the past 2 seconds, this function create position. I'm looking for the most active functions and see if they have events that I could track. Create position seems to be also not called very often. But you see now, this is a utility of this kind of operation, that every time there's a response from the blockchain, you can get it in real time. So for instance, now I'm looking for the create position events. It was called in the last 3 seconds, but maybe in the next 5 minutes, no one will call that function. What I want with my application is that when the create position method is called and its events are emitted, I get that information right on time, rather than me having to query my indexer or the blockchain directly for that information before I can receive it. I want to receive it right away when it happens on the blockchain. Through my WebSocket connection, I should be able to access it, have it both on my back-end server, and then have it on my front-end server, on my front-end application. So that is the purpose of this persistent WebSocket connections. And I think we have successfully looked at some of the things that might be critical to WebSocket interactions and communication, unless there is something that I might have left out. So tomorrow we will definitely look at a third-party WebSocket, something like, is my screen still visible? So yeah, tomorrow we'll look at a third-party WebSocket and see how we can interact with it. Specifically, I'm trying to find one that does not require me to make a payment, that gives me a period of allowing me to pay somehow. Rather, allow me to have a free period where I can try it out before I can pay for it. Then within that period, we can test out all the different things that you can interact with. So beyond just you having a link like this, of course, WebSockets can also have query parameters, like we were looking at them the other time. But basically, for Web3, you don't really need to have a lot of parameters.
Okay, so the very last part is going to be us using the custom smart contract. So from the event we were tracking, you could see it was an ETH mainnet, and this was the ABI, and then this was the specific address of USDC on ETH mainnet. So first of all, I want to change this. Oh yeah, I think we worked with this before. We tracked the approval function, although it wasn't very active. So what we're going to do, we are going to first of all shift to the USDC on Sepolia and track the approval function, and then switch to a custom smart contract and see how we could actually do exactly the same thing with a smart contract we defined for ourselves. So I won't be working with a client because we've already seen how we could display data on the client. But for now, we're just going to be working with a terminal and maybe with Postman, because it doesn't require a lot of setup. Since we've already done client visualization, so it won't be very difficult to do exactly the same thing. Now, starting here, you could see this WebSocket represents ETH mainnet. So I want to switch on to Sepolia. So for the first thing I will do is look for the USDC contracts of USDC contract on Sepolia network, and the assets I'll be able to find it. So now I want to reconfigure my back end so that it's instead now tracking a different chain and of course a completely different smart contract. But like I said, if you fail the configuration, everything else will not work, and you might not know why until you figure that out. So I'll be tracking Ethereum Sepolia, USDC on each Sepolia. So there's a number of things I'll have to change. One, I'll have to change the address like I've changed it. And then also I'll have to change the WebSocket provider because now this references ETH mainnet, not Sepolia. Okay. So then I'll have to go to chain list and now track Sepolia. Sepolia, include testnets so I can get a WebSocket provider of Sepolia, excuse me, instead of me using the one for ETH mainnet. So I'll pick one from here, particularly one for WebSockets. So this WSS sepolia.drpc.org. Then I'll paste it here. So now this is our new WebSocket provider on a different chain now, tracking an address deployed on that chain. But I'll be tracking the approval function. I'm actually going to probably call it. I'm going to invoke it since I don't want to build an entire interface for interacting with this specific smart contract. I'm just going to call it using Foundry, and so that we're able to see the events that we're tracking here when it's displayed. So specifically, the approval function is used for assigning spending rights to another address, but specifically now the approval event, which is emitted in that function when it's invoked, has three parameters. It displays the owner of the funds, then the person that has been assigned the spending rights, then the value that has been assigned to that person to spend. So I'm just going to change this so that it has appropriate names: owner, spender, then the value. Then I'll just change this to owner and then this to spender. Oh, I used lowercase. Even this was lowercase, so that means I also have to change it in the message that is being sent to the client. This is now owner, and this is spender. Then the value sticks. So I'm going to run my client unless there's any other configuration you think I've missed out. So this is the approval event that I'll be tracking here. And this is the specific USDC address, contract address on Sepolia. Then I've also set up the WebSocket provider. So everything seems to be set up. So I'm just going to call this method on using Foundry. So let me check if I have any wallets here that have any funds. Let me check the list. I think I have a number of wallets here. Yeah, I think Approve might have because I might have used it yesterday, so I can check its balance. This is a specific framework that we'll look at, smart contracts interaction and deployment framework that we'll look at. I'm using it because I don't want to go into struggling with my browser extensions. They kind of slow down every time I'm recording, so I'm choosing to use this because it will help us get through this faster. So cast balance, then the address I'm looking at. Specifically now I'll be getting the wallet address of Approve. I think it ends with BA. It's one of my wallets. Just a moment. Let me stop sharing and copy it. I stored it somewhere, but it's a private secure environment, so I don't want to share it on screen. I could also decrypt it from the key store, but that will take me a while, so I'm going to stick to just getting it from here. Okay. Alright, I hope my screen is now visible again. Okay, so when I come to when I come back to Foundry, I want to check the balance of this wallet. That's the wallet address. Then I specify the RPC of the chain that I want to be getting this balance, the balance of this wallet from. So it's exactly Sepolia. So I can get it from here. Any RPC that will be able to allow me interact with the chain and make these static calls. I could use this still. Could just paste it here, then make a request and see how much money I have. Oh, I still have some funds here. Also, I could put this in a variable, in a local variable inside my console.
And store it there. So every time I want to access it, I'll simply get it from the local variable right there. Okay, so that gives me that. Okay, so I have some funds, as you can see. Now I want to call this specific smart contract called approve function, so that I can have this event emitted because I am tracking it here. To be able to see that event, I need to start the server, and then also I need to, because it's all running inside the list now, the WebSocket server for connections, I need to connect at least one client, so that those events will then be emitted and displayed on my console. So I'm going to open Postman and connect Postman as my single client. Okay, it's already set up there. So I'm connected. You can see there's a new connection. So I'm waiting on the approval event to be emitted. Then I can get the results. Okay, so I'm going to call it here. Cast send. This one is for post sending transactions.
So yes, I'm going to call cast send for sending transactions, and I specify the address that I'm going to be interacting with, which is this address, and yes, and then I specify the function I'm going to be calling. So the function is called approve, and it takes in two parameters. One is an address of the spender, then the value that I'm assigning to that person. So the next would be passing in these parameters, these specific arguments. I'm going to use a random address, I think. Let me assign this address. Okay, you can see they are already approved. The approve method is already being called on Sepolia, but I'm specifically going to be tracking my very own transaction, the one that I want to see. So I passed in one parameter, rather one argument, which is the address. Now I need to pass in a value. So maybe I want to assign 6 USDC tokens. Assign spending rights to this person to spend 6 USDC tokens. So because USDC has 6 decimals, I would have to put 6 zeros after the 6. Okay. So now I'm spending that amount. I'm assigning this person to spend this amount from my wallet. Okay. Then the function, I need to specify the account that is going to sign the transaction. So the account that we saw earlier called approve will be signing the transaction. So it will be the owner of the tokens. And yes, that will be the account. Then the RPC URL of the chain. Sepolia. So from this, I should be able to see the transaction. So my account ends with EA, and we should see this value 6,000 here. 6. This is actually 6 in terms of USDC. Just that it has 6 decimals. That's why I have to put it with 6 zeros after it. So I should be able to see that transaction here, emitted with an event. That the owner will be an address ending with EA. Then the person that has received the tokens should be an address ending with F5C. If I enter the correct password, the transaction should be accurate. So it was an incorrect password. Let me repeat it, and then we can view our console. can view our console for that specific event emission and see if we can find it when the transaction is complete. So it's not yet complete, but immediately it's complete, we should be able to see, you can see that event is right here, emitted directly from the blockchain. So the owner of the tokens was this, which is my account ending with EF. Then I was assigning F5C a right to spend 6 USDC tokens on my behalf. So if I want to actually verify this, I can check for the transaction hash here and see if that's the transaction that was exactly invoked. I can, let me go to Etherscan and see this transaction in particular. But on testnet, which is Sepolia testnet, I should be able to see this. As you can see, this was me calling the approve function, or it's actually 0.6 USDC. I was assigning this address. Rather, this is the smart contract. I was assigning a certain address. I can see that in the logs, the event logs. I was assigning this address right to spend 0.6 USDC tokens on my behalf, and my address is 6DEA. If you remember, that's the address I checked balance for. And if I check the balance again, you'll see that the balance reduced because I used some of it to pay for the gas fees. This was 948. Earlier on I checked, but I think I cleared. Okay, that's fine. So now we have seen that it actually works even with addresses on different chains, not just Ethereum mainnet. So we can define our own smart contract and track a specific event that we defined on that smart contract. Okay. So that should take us a very short time. So I'm going to create a folder here and name it our own. I won't call it our own contract. When I change into it, I'll just create a Foundry project. So I'm going to go through this first because we'll have the time to look at this as a framework itself, but I'm only using it because it's the fastest way for me to do this without having to go through the hassle of waiting on my browser wallet to run transactions. Okay. So I'm going to create a simple smart contract and define an event inside that smart contract. Then we're going to be tracking that smart contract event particularly. So when I call that function, I should be able to see that event being emitted, then being tracked on my back end. So I could see that the event has actually been called, has been emitted rather. Okay, it's taking a while. Alright, so typically it comes in with a simple smart contract. So I'm going to delete this. I'll keep it at 13 still. Okay, I'll define a simple smart contract in here in the source folder. That's where I usually define them. So I'll say our own. So then these are preliminaries for smart contracts, but if I look at them, use an IT, then the version, maybe I'll use 0.8.20 and call it our own. Then in here I'm going to define one event and call it tracked. So this is the event I'm going to be tracking. Then I'll give it two parameters. One is an address, maybe call it owner, and then maybe still a value, or let me say a boolean value called status, and perhaps a uint8 called value. Okay, Then I'll define one function called tracker. First, I want it to be public so that it's visible for me to make external calls on it. And then inside here, I'm just going to emit the events. I'm not going to do anything else. I'm just going to emit the events and pass the arguments into the events parameters. Emit, tract, I think it's called tract. So for the address, I'm going to just manually generate one because I don't want to start looking for addresses. Now I'm just going to manually generate one. And we'll look at all these things. So an address is a uint160 just converted into 56 byte 32. And yeah, we'll put here just a random number. Okay. So the second parameter is a Boolean value. Maybe I would say it's a true. Then the third parameter is a value, so I should just put a random value here, maybe 3, 4, 5. Okay, so don't worry about everything here. This we'll look at it when we're working with smart contracts. Okay, then inside scripts, I'm just going to define one script for deploying my smart contract. On.s, that's all. So I'm going to import the components that I need. Standard library. Okay, so that's it. And sorry. Now I'm going to also import. I'm also going to import the smart contract here. It's called our own. Our own. I'll import it from and get out of SR script and can go to SRC. Yes, and here I have a file called our own. Just a moment, please. I have a file called our own. So I'm going to call this function our own deployer. Yeah, shall look at all these things. I'm just doing it faster because I want us to get done with it, and then you can see how we can track our own smart contracts. So inside here, you should always have a function run. It's the one that is responsible for deploying the smart contracts. First, it has to be public. Then inside here, I will deploy my smart contract. So I will declare a new instance of our own smart contract. This is all that I need. Okay, so that's all that I need. Now I'm going to deploy the smart contract. Simple as that. Okay, our own. So I'm going to deploy it on Sepolia. Then I'll call that method on it. It's our own.sf. Our own deploy. Our own deployer. Then the account will be approved. I think I have some funds there. The RPC URL will be Sepolia, and I'll broadcast this to the blockchain. Okay, I'm not saying it fully. I think that's it. So it should allow me to deploy. I forgot to put, so for Solidity you're always supposed to use these tags at the end, semicolon, because it requires them for you to continue execution. Okay, so it's compiling. Just does not specify compiler version. That. Oh yes, we have to do the same here. SPDX. I'm going so fast, so I might forget certain things. I can always get back to them. Okay, I think I used 0.8.20. Yes, 0.8.20. Anything else? Is there an issue? Just basic troubleshooting, but everything should be fine. Compile it in file with source C2.0. Type coding available for. Okay, I think this number is too large. Let me make this a in 16 perhaps. Convert this to 30. I think other dependencies are on that value. You can work with that still. Okay, it's successful. It should request me to enter my password so it can deploy the smart contract. Okay, so we should be able to see the smart contract address here. Then we'll configure it for us to have that specific, to track that specific event. Okay, so this is a contract address. We can verify that on the block explorer, but I won't get into it. So let me just stick to the contract address. So yeah, I think I'm done with this specific file, but let me still go back here. So now I'm going to change the contract address because I'm going to be tracking a completely different contract address, and that's the address. Then I'm declaring a contract instance here. That means the ABI also has to change. So I'm going to declare a new ABI. I'm going to call it ABI1. And like I said, it's an array of signatures. It's either signatures of functions or events. But specifically, I'm going to be tracking an event, this event tracked here. So when I paste this here, that's the signature of the event I'm going to be tracking. Now, even on the contract listener, I have to change the event I'm tracking. So this is the event that I'm tracking. It's called tracked. Tracked has three parameters. One is an address called owner. The other is a boolean called status. The third, I'm going to name this status. They could have really any other names, but I'm preferring to stick to the names that I used in the definitions because then it becomes much easier for us to follow through. So the second parameter here is status, and it's a boolean value. Then the third is a uint16, which is value. Okay, so I think everything else is this is status. So we should be able to record these event emissions and all the parameters, the arguments that were passed to the event while it was being emitted. From this is owner, this changes to status, and then this is value, which remains. This is status, that's value. Yeah, that's it, I think. So I'm going to run this again and then connect my client once again, but it disconnected because of an error I'm about to find out. Unknown fragment. Oh, I didn't change the ABI. So it was trying to check for that specific event on the ABI and it wasn't finding it. So I had to change the ABI in the contract definition here. Okay, so I have my server is online now. I can connect. So I'm connected, and now what I have to do is send a transaction to this specific smart contract so that it can emit that event when I call that function. So I'm going to do it still using Foundry. Let me use this other terminal. I think it's the very terminal. I'm going to call that. Just a moment. So this is the smart contract I'm going to be calling, rather invoking, rather sending a transaction to. So what function am I going to be calling? There's a function called tracker. It doesn't take in any parameters. So I could just define it like that. Then I specify the account that will sign the transaction. It's called approve. They are specifically private keys, but they are encrypted in a format which is indexed to a name. So every time you put that name, it gets that file that is encrypted, then you put in the password that decrypts it. PC or I think it's Sepolia. And that should be it. So what I'll be waiting for is to see that event emitted here, giving me all this information and then sending that message to the client. So yeah, this is it. I enter the password and I should see the transaction completed. And so this means that if you define your own smart contracts, you can still track events on those smart contracts. So it was a successful transaction, and you can see the event was emitted here. It says the owner is F9, and I think what we were trying to do. So this is an address we just randomly defined here when we were creating the event emission. Just defined it randomly, then the value true, then 345 as the last value. So you can see here in the event emission, it defines, so it resolved to that address that we generated randomly. Status is true, the value is 349. Was the value sent? Yes, the value was sent to the client. So this is something you could do. So you could define your own smart contracts, and if you're able to track these events on those smart contracts, you can build applications that are fully responsive and transmit data in real time. And yeah, essentially that's the very last part that we had for this session. And I'm glad you all made it. Have a good evening.